Namaskar my dear friends. Let us talk about LTSpice Simulation schematic demonstration. So what we can do is we can see some of the opamp applications. So in this session what we will try to understand is how to design inverting amplifier in LTSpice and simulate for our particular gain. So as you already know, this is the inverting amplifier configuration. Like let's say we have the input voltage V input R1 and R2. So R1 and R2 are actually going to set the gain of the output voltage. So V output will be minus R2 by R1 into V input. So as you can see, we have one opamp and we are going to see the input and output. So this is the green one which is going to be input, which is the green one, this one, and this is a V out which is going to be this one. So as you can see, gain is set how much it is, 10k 10k and plus 1. So this is non-inverting input, so not a problem. We'll try to first see inverting and then we'll see non-inverting. So inverting, as you can see, non-inverting, you can see here gain is set 2, so that is output is 2 times. Anyway, let's open LTSpice, and what we can do is we can quickly open a new window, schematic new window. Okay, now what do we have to do is we need one opamp to put in, and so that we can run this particular simulation, and we are going to see inverting amplifier with a gain 1 2 like that. We'll try to vary and we'll simulate the functionalities. So go to this part and put opamp. Okay, or maybe if you want you can write down some parts as well directly. So if you know OPA parts are very good ones, so you can see OPA parts are there. So OPA 1177 I'll just take. If you want, you can have always an understanding of open example circuit. So this example circuit will be open directly for you and you can simulate it very easily. Okay, however, I'm not going to do that right now. I'll just teach you first like how to design your own circuit and do the inverting amplifier simulation. So just place this particular op-amp here. Then we need two resistors, right? So one resistor will be here at the input, another resistor will be at the feedback side. One more resistor, if you want, we can keep it at the load. Okay, got it. So this is done. Now coming back to the input voltage. So we need a voltage supply which will be used as a input voltage. So this will be used as input voltage. Another thing that we need is we need the supply voltage for the op-amp as well. So for that, let us set two voltage supplies we need. So I'll just put one voltage supply here and one more voltage supply here. Okay, that's all. So my circuit is almost done. Now we'll just put it grounds. So one ground is required here, one more ground is needed here, one more ground is needed at the non-inverting terminal, and two grounds will be required for these. Okay, I'll just put it here, just delete one of them. Okay, so my circuit is almost complete. Now let us quickly wire this up. So press W to wire up. You can always rearrange your circuit to best suitable to your understanding. Okay, you can make it very beautiful. This is always a good practice to make little better circuits. Okay, what we can do is we can take up, or let me just draw this like this. Hope you are able to understand this. Or what we can do is we can stretch this one little bit outside, and maybe we can stretch this line like this. Now it looks beautiful. We have this ground, so this ground will go to non-inverting input. Now let us define all the parameters. So I am going to define for one gain 1. So I am going to do let us say this is my 1k. So this will be also 1k. It will, the output will be just inverting of the this thing. And what we can do is we can initialize a supply voltages. So let us say I am going to put net name here as well. So this will be my net name N. Let us say this is going to be VCC, and this will be, let us say, VEE. I'll just put here VEE, which will be negative supply, and VCC will be my positive supply. That's all done. Now this particular should be grounded. we have, let us say, DC voltage I am going to keep for VCC as 15 volt and VE as minus 15 volt. Okay, so positive negative both will keep, so that we can simulate in the both direction. Now positive supply is connected to VCC, so what I can do is I can either connect directly or I can write the net name to connect that to VCC. So this is how it is connected. Okay, so you don't have to physically connect them here. It means VCC is connected to my supply voltage. Okay, I can move this one little more this side and this one here, so it looks now better. Okay, one more thing is negative supply I can put it to VEE. So VEE. If you want, you can put your own names like V plus, V minus, something like that. So that is not a problem. So my circuit is now complete. Hope you are able to understand. Now what we can do is the load resistance we can do, let us say 10 kilo ohm. Keep it little bit higher load so that current supply will be less, and we can put the net name so it will be easy. So this is my V input net and this is my V output net, so that we can see what is the input and output. Alright, now let's decide my V input signal to be a sinusoidal signal. So I'll just put a sinusoidal signal of 1 kilohertz. So DC offset I'll keep just 0, amplitude let us say I'll keep 1 volt, frequency let's say I'll keep 1 kilohertz, time deal I'll just keep 0. Okay, so this is my sinusoidal signal that has been decided. So this is the circuit that is there for inverting amplifier. If you want, you can write a note as well by pressing this T, which is blue color T, or just T, then you will be able to get your comments window and inverting amplifier. So inverting amplifier simulation is the heading of this particular window. Let's configure the analysis. So we are going to configure the analysis. What you can do is stop time you can write down. So since the signal is for 1 kilohertz, so it means the time period is 1 millisecond. So we can run it for, let us say, 5 millisecond to get 5 pulses or something like that, and we'll start saving data from 0 onwards, like beginning onwards. Okay, now let's run this circuit. I'll just keep it right side, so it is right side. So what is my input voltage? As you can see, input voltage is 1 volt peak to peak sine wave, and my output voltage is expected to be inverted but gain 1. So same 1 volt peak to peak, but it will be inverted. So whenever it is going high, the output will be low. So you can see V output is going low. Understood? Or if you want, you can go into another window. Let me just keep it down, and this is up. So as you can see, whenever my input is upward, like positive half cycle, my output is negative half cycle. That is very easy, right? And for 1 millisecond it is going up to 1 millisecond is the time period. So from 0 to 1, you can see from 0 to 0 it is reaching. Okay, now let's do something. We can increase the gain for this R2 as let us say we are going to put 2 kilo ohm. So what will happen? The output must be minus 2 and plus 2. So I can rerun it and see. As you can see, my output has reached to minus 2 volt to plus 2 volt. Okay, if you want, you can keep very high values also. Let us say 10k we want to keep. So my gain should be how much? Plus minus 10 volt, plus minus 10. So gain will be actually minus 10. So the output will be minus 10 volt plus 10 volt. So I can rerun it and see. Plus 10 volt it is reaching and minus 10 volt it is reaching, and V input is 1 volt peak to peak. Okay, so this is what this is how we are going to simulate our inverting amplifier. Let us quickly do one thing. I'll just take the same circuit and take a different source so that you can understand. By changing the source, we can easily simulate this particular circuit. I'll put voltage source here. Let us say I'm going to put here voltage source 0.2 2 volt. Okay, or 0.2 volt, that is more than enough. Okay, so what will happen? The output must be 0.2 times 10. This is 10 gain, right? So output will be 2 times 10, that is 2 volt. So let's run this signal, and this is the window that we are going to see. My input is 200 millivolt, okay, that is 0.2 volt, and output should be 2 volt. So you can see my output is inverted, which is negative, and 2 volt. You have to make sure only one thing: the gain must not exceed in such a manner that output goes beyond 15 volt, okay. If you see you make the output go to beyond 15 volt, then the output will get clipped. So shall we make that change as well? Let us say I am going to make here gain change as 20. In this circuit, gain change as 20k. So what will happen? The gain is actually minus 20, so the output is expected to be minus 20 volt. Let's see what it happens. So as you can see, my output is clipped at 15 volt itself, okay. If you want to see very properly, what we can go is, we can go into the scale, and we can, sorry, right side y-axis scale, and we can keep it, let us say 20 volt top, minus 20 volt bottom, okay. So you can see it has been clipped, it is not reaching to 20 volt because the supply itself is 15 volt, okay. So this is how the complete understanding of inverting amplifier simulation in LTSpice that we have seen. And you can change your input pulses as long as you want, whether it is a DC pulse or AC pulse or sinusoidal signals or whatever it is. Your aim is to just get a particular opamp, and then you can simulate this particular circuit. So hope you have a very good understanding about how to simulate this particular inverting amplifier now. Now we will do quickly is, we can open the example circuit that is given in LTSpice directly, and we will see that as well quickly. So what we can do is just remove all these things, open a new circuit. So how quickly we can draw that particular circuit, I'll just tell you. Let us say I'm going to take another op-amp, which is OP2177. If you place this part, again you have to draw all the circuit by yourself. So what you can do is, here there is a window, there is a button which is called as open example circuit. So open example circuit, if you do, the circuit will be opened for you, okay. So you can see we have input signal, which is a 10 kilohertz sine wave for 1 volt peak to peak. We have output defined here with a load resistance of 10 kilo ohm, and we have, this is inverting amplifier actually, okay, sorry, non-inverting amplifier actually. So with gain 2, so whatever the input voltage is there, the gain will be twice of that, and this is the supply voltage for positive supply and negative supply. And if you run them, then it will give you the output, like this is my input signal, which is a sine wave, and this is the output signal, which will be twice of that. So you can see 2 volt peak to peak, and green one is input voltage, and output is little bluish one, which is 2 volt peak to peak. Anyway, we will see the non-inverting amplifier in our next session. Thank you so much.